Hi everyone, welcome to the next series of videos in this course on AI and cybersecurity. If you've been following along so far, we started with an introduction into AI, how generative AI hallucinates. One of the ways we address that is through retrieval augmented generation or RAG. We built our first chatbot, we hacked a chatbot. We moved on to the magic of AI, which is agentic AI, where agents are given a set of tools and then they figure out the tools to call, the sequence to call the tools in, and process it given a particular objective. And then we looked at how to hack agents as well. Then we moved on to MCP and we looked at the nuances of model context protocol, what security it brings, what it does not bring, and how MCP servers can be a source of compromise and they can also be a target of attack. In this series of videos, we're going to explore multi-agent systems. And I'm super excited because I built my first multi-agent system and it was quite magical. So let's explore what these multi-agent systems are. And the reality is that for practical applications, a single agent may or may not suffice. And the general consensus from Google and Anthropic and deep learning is that agents perform best when they perform specific tasks. And if you overload an agent with too many tasks, the output may not be optimal. And therefore, what we're going to do is we're going to build a multi-agent system. Think of it like a team. Each member in the team has their specific tasks. These agents can talk to each other. That is one pattern you can set up. The agents can have a manager on top giving them guidance and calling each agent based on what the manager agent feels is the best approach. Or it can be just a sequential execution of the agents. So these are the different patterns that we have when we build multi-agent systems. Um, and multi-agent systems bring in decomposition of tasks, specialization, and efficiency. We looked at one example, which is an hierarchical system. There is a manager agent and worker agents, and the manager kind of figures out what tasks to call. Collaborative, where agents kind of sit around the table and iterate amongst each other. Or a smart assistant model, a primary user facing agent takes the user instruction and then figures out which other agents to call. So with that, let's build our first multi-agent code. We're going to use a library called Crew AI, which again abstracts a lot of the complexity away for us and gives us a lot of insight into how multi-agent systems operate. We will be using a sequential pattern, and let's take a look at the code. So enough of the theory, and let's explore what our code looks like. Again, this code is extremely simple for the kind of complex tasks that it manages to do. We're importing two libraries here. From Crew AI, we're importing a bunch of modules. And from Crew AI tools, we're importing this SerpAPI tool. SerpAPI is a Google approved tool for searching on Google. It's a free tool. You can go and create an account on serper.dev and just basically get a key and copy that key into your environment variable so you can actually run Google search through your code, right? Uh, this part is just in case we want to set up a .env file, but I've just always put my API keys into my environment variables, so they're all already there. We initiate the tool. This code has additional uh, lines of code just to fall back onto another search tool called DuckDuckGo in case there is some problem with using Serper. But my Serper works fine, so we will actually not be using this alternate method. Now, we're creating two agents. When we discuss about prompt engineering, one of the things that we talk about is how do you craft a great prompt? And many of those components you see when we are creating an agent. So we're giving the agent a role, we're giving the agent a goal, We're giving it a context or a backstory, as it's called. This parameter is called a backstory, but it's essentially a system prompt to the agent. We're saying, please be verbose, give us more output on the command line. Allow delegation is false is a very interesting parameter. This means that the researcher agent cannot further delegate work to any other agent in the ecosystem. But it does have access to tools, and it has access only to one tool, which is the search tool, because that's its job, to research. The second agent that we are creating is the writer agent. Again, it has a role, it has a goal, and it has a backstory. Again, verbose equal to true. In this case, we are telling the writer agent it can actually delegate tasks to the researcher agent, and we shall see this in action. The way that it works is that first, the researcher tool does the research on a given topic, extracts all the relevant documentation, summarizes it, gives it to the writer agent, which is then tasked to create an engaging output. Take away all the jargon and create that into an engaging narrative. If the writer agent feels its goal has not been met, if the research is not complete, it will actually, because of allow delegation equal to true, go back and get the researcher agent to do further research. And all of this happens magically. And that's the amazing part of multi-agent systems. I am not telling it to do this explicitly. Then we create the task for each agent. So we give it a description, conduct a thorough analysis of the latest developments in quantum cryptography, whatever you want to give it, identify key trends, breakthrough technologies, and their potential impact on the cybersecurity industry. Your final output should be a bulleted list of the most important points and a brief summary. So this is for the research agent. The task is being assigned to agent equal to researcher. This is the expected output. So these are the parameters of a task in the Crew AI module. And similarly, the writer agent is being given this task that using all of this research now create an output. And that's pretty much it. And the rest of the magic is essentially here, where we are now creating the crew of agents. We are calling it tech crew. 2 agents, 2 tasks, sequential, not hierarchical, and verbose equal to true. And that's pretty much it. Kick it off. There is no actual logic, if then else. There is no evaluation being done. In this case, there's no human in the loop as well. And that's pretty much it. We go ahead and execute, right? So let's now execute this piece of code. So let me open up the command prompt, navigate to my folder, and initiate the virtual environment that I have created. This requires a separate set of requirements. I have already installed those. So these are the requirements: the Crew AI version, Crew AI tools, Python .environment, which we're not using, in LangChain community for the DuckDuckGo search tool, which also we're not using. So pretty much now we should run this. Let's look at some of the interesting stuff that happens as this code executes. So because of verbose equal to true, we can actually see the agents in action, and it's pretty fascinating. So, here's the agent, here is the thought that it has based on the goal it has been given and the backstory, and it's going to use the SerpAPI tool to search the internet. Okay, so this is just the inputs that we gave the agent, the role and the task, and then it's figured out all of this. And then the search query that it's running is latest advancements in quantum cryptography 2023. I don't know why. So this would be obviously something to fix. Fortunately, the results we're getting are from 2025. So thanks to Google being smarter than the code. And then the agent retrieves all of this, analyzes, synthesizes, and creates an output. So it was asked to create a summary bullet point output. And Now the professional technical writer has started its job. So this task got completed and now it's starting its job. And here you see something very interesting happening, that when doing its job, it feels that it needs more research. So it actually triggers the research analyst again because it had delegation equal to true. And this is the task it has asked the research agent to trigger again. So there is another search going on now. You can see that this is the second time that the search tool is executing, because now it needs to correlate what it found with cybersecurity, right? And so it runs a second search, which is super cool, right? None of this, as you saw in the code, was hard coded. I have not asked any of these agents to run multiple times, but the writer agent, which had delegate equal to true, has triggered the research agent to run twice with two different queries. And now I have a final answer from my research agent. And now I'm going to start writing the engaging blog post. And you can see that now I have an engaging, hopefully engaging blog post. The emergence of quantum computing heralds a new era, blah, blah, blah. Moreover, advancements, whatever, right? I could convert this to a LinkedIn post, a LinkedIn article, etc. And then this is the final answer I have. And crew has now completed executing the tasks, and I have an output, right? Um, which is pretty brilliant. I hope you found this as cool as I did. The first time you have these things executed, almost seems like magic, and then you kind of get used to it. But I'm still in that vibe of, oh my God, this thing actually went, did 2 rounds of research, synthesized those 2 rounds of research, and wrote me this final report. If you don't like this report, you're welcome to play around with the code, improve the prompts, improve the role, the backstory, the prompts given in the tasks, and see if you could get better output from this research assistant. So I hope you found this enlightening. And as we move forward in the second and the third part, we will now try to break this multi-agent system. Again, this was a very simple multi-agent system. In the practical world, we will look at dozens of agents working and coordinating with each other and giving output. Imagine you have multiple agents doing different things today that happen in the security team: a threat intel agent, a vulnerability management agent, a GRC agent, a consultant agent that understands policies and regulations and standards and frameworks very well, a risk analysis agent. And imagine hundreds of these agents running, gathering security intel, talking to each other, gathering insights, and working almost autonomously to achieve the final goal. And in the next video, we will discuss how do we hack a multi-agent system such as this. So see you next time. Thank you for watching.